Hello! It's great to see you again in a video. There's a space theme. Do you know the average human lifespan? Or is it the time that you can survive on Earth? According to the world-backed book Facebook, 2016 edition is about 69 years, 67 years for men. It's about 71.1 years for women. Earth, it's also the only planet in the solar system. There is a human presence. Simply because Earth is the only planet in the solar system. They have the perfect elements to sustain life for humans. All the other planets are made of Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. It's too harsh for humans in particular, and with life in general. But have you ever wondered, people who are closer are you and me, how long can survive if unfortunately teleported immediately down to other planets in the solar system? Note that there is no protective gear. Welcome to the first universe, the solar system version of Survival Challenge. Let's start with Mercury. No, let's start with the Sun. You'll evaporate almost immediately after appearing on the surface of the Sun because the temperature here is 5,505 degrees Celsius. Enough to melt anything. You can find it on Earth. It's made up of 65% oxygen, 3.2% nitrogen, 1.5% calcium, 1% phosphorus. You do. And less than a second is time. You can survive on the surface of the Sun. However, you may survive longer if they're transported at night. Because where does the night get the sun? Come to Mercury. It's the closest planet to the sun, with an average distance of just 58 million kilometers. Mercury, logically speaking, must be the hottest planet in the solar system. But because there's almost no atmosphere, Mercury has no way to keep the heat that it gets from the sun. That's the direct reason. That makes Mercury a planet. It's a temperature difference. It's bigger than any other planet. In the solar system, it's 427 degrees Celsius during the day and minus 179 degrees Celsius at night along the equatorial zone. That means you'll burn to death, face towards the sun, and freeze to death on the face turned away from the sun. Fortunately, the Mercury rotates very slowly. The planet takes 88 Earth days to go all the way around the sun. It took 176 Earth days to turn a full circle around your axis. This means that if you're transported to the boundary of both hot and cold plates, the temperature will be ideal enough so that you can survive in less than 2 minutes. The reason is because Mercury's atmosphere is too thin to be able to sustain life. In fact, the gas pressure at the surface of Mercury, it's equivalent to gas pressure in the outer sphere of the Earth. 700,192,200 kilometers from the surface of our planet. To make it easy for you to imagine that most of the Earth's artificial satellites are moving in low Earth orbit. It's only 2,000 kilometers from the planet's surface. What does that mean? The time that people could exist on the surface of Mercury in the warmest places will be equal to the time that we can survive in the vacuum of space, about 15 seconds before you lose consciousness, hypoxia to the brain, and about 90 seconds before completely suffocating. Venus. It's like the twin sister of the Earth. Due to the size, ownership, and structural composition, it's similar to our planet, but different from Earth. Sister named Venus. It's got a super dense, super toxic atmosphere with 96.5% carbon dioxide, 3.5% nitrogen, and extremely small amounts of other gases. Carbon dioxide in the atmosphere of Venus has a very strong greenhouse effect. It captures the heat it receives from the sun. This is why the sister of the Earth. It's not closest to the sun, with an average distance of 108 million kilometers. It's the hottest planet in the solar system, has an average surface temperature of up to 464 degrees Celsius. That is equivalent to temperature in a pizza oven. In addition, the atmospheric pressure at the surface of Venus, up to 92 atmospheres. That's 92 times more atmospheric pressure at the Earth's sea level, at the same time as the pressure at the depth. It's almost a kilometer under the Earth's oceans, which means that right after being picked up on Venus, your body will be squeezed. You'll suffocate. They died and were eventually baked into pizza. Wrong to ashes. and 12 seconds is the maximum amount of time you can exist on Venus. Earth, it's the only place in the solar system where you can live. Instead of just trying to survive, you will be able to breathe freely, can find water to drink, find fruit, animal meat to eat, can be active in the community, and can have private activities for 2 people to increase the population. However, that if you're dropped into a safe location, the Earth is basically friendly to humans. There are countless places, can kill you in seconds, until a few days. For example, a crater, hot springs, geyser, large lakes, or between the oceans. On the high mountains, where the temperature is low and the air is thin. Into cold polar regions where temperatures can drop to minus 90 centimeters. minus 90 degrees Celsius. Or deep and dry deserts, millions of square kilometers. Let's go to Mars, the outermost rocky planet. Unlike his name and appearance, Big Brother Mars is a pretty cool guy. The average surface temperature of the planet, it's about minus 63 degrees Celsius, and as low as minus 143 degrees Celsius at the 2 poles. The good news is that in the summer, temperatures can reach up to 35 degrees Celsius around the equator. The sad news is, even if you're at the equator of Mars, in the summer you won't survive long. We're the atmospheric pressure at the surface of Mars. That's about 1/159th of the Earth's atmospheric pressure, with only 0.006 to 8 atmosphere, compared to an atmosphere at the Earth's sea level. This figure is significantly lower than the Armstrong limit where atmospheric pressure is low enough so that the water can boil at 36.5 degrees Celsius, which is the normal temperature of the body. That means it's sweat, saliva, tears, mucus in the nasal cavity, and all kinds of liquids, not in the closed systems of your body, will boil and evaporate almost immediately. The air in the lungs will expand and rupture the lungs if you're not quick, pushing them out of the body. Oxygen in the blood and the rest of the body will also expand. You're not going to explode, but you're going to inflate a little bit and get fat. Similar to the surface of Mercury, you'll be unconscious in about 15 seconds and die after about 90 seconds. Jupiter, the largest planet in the solar system, is a gas giant planet. That means it's huge and it's made mostly of gas, but more specifically from 89% hydrogen and 10% helium. Unlike the 4 terrestrial planets, Jupiter doesn't have a solid surface, which means you won't be able to land or standing on Jupiter. Your fate right now will depend on where you're going to appear in the atmosphere of Jupiter. If you're dropped from too high, that means the air is too thin. The atmospheric pressure is almost zero, and you will die in the same way that you die on Mercury or Mars after about 90 seconds. If it's moved to deep, you'll be squeezed by the tremendous pressure of Jupiter in less than a second, then burned to ashes or into something that we haven't even imagined yet. And eventually, if we're transported to the atmosphere, has the same pressure as on Earth, you'll suffocate from lack of oxygen and freeze to death at minus 108 degrees Celsius after less than a minute. It's the same for Saturn, another gas giant planet. Uranus and Neptune are 2 planets on the fringes of the solar system. They're called ice giants. That means they're huge. And there's a lot of ice inside, with the ice here being essentially water, methane, and ammonia. Exists in extremely hot and extremely dense liquid states. It's about the interior and the exteriors of the ice giants. It's pretty similar. The gas giant planets. It's made primarily of hydrogen and helium to form these violent currents. According to Wikipedia, the wind speed on Neptune can reach up to 600 meters per second or 2,200 kilometers per hour, and the strongest winds that you can find in the solar system. To make it easy for you to imagine, the strongest winds on Earth, it's only about 113 meters per second, and the velocity of sound in the air, it's about 343 meters per second. Not just strong, the winds above or the ice giants are still cold because it's farthest from the sun. Not hard to understand. when the atmospheres of Neptune and Uranus are the coldest atmospheres in the solar system, with the lowest temperature in turn, -218 and -224 degrees Celsius. You're going to die if you drop it. Uranus and Neptune. How to die and time of death will depend on where you're in their atmosphere, similar to the example of Jupiter. In short, the universe is a scary place, and best of all, then people should stay on Earth. Hello! It's good to see you again in a space video by Mr. Tan Facts. Do you know what happens if you fold a piece of paper 103 times? Time always stops for a photon, or NASA boosters. What kind of fuel do you use that gives off so much smoke? Welcome to Space 2 NASA-style silencer. In the West, they have a default sentence that roughly understands. It's a legend, the accumulation, a rumor spread among the people that you can't fold a piece of paper more than 7 times. It sounds fictional, but think about it. You'll find it quite persuasive, where every single fold, the thickness of the paper doubles, and the force required to fold the paper, it will also increase. It should also be noted that the legend of folding paper has been cracked, understanding that it's been deciphered, broken, by using a giant sheet of paper. Or a paper that's big enough, but it's really thin, and it's so soft, like this napkin, for example. In fact, the Guinness World Record in the category, the largest amount of paper folding, it belongs to Brittany Gallatin, an American, with 12 times the performance, using a 1,200 meters long toilet paper. Still related to paper folding, did you know that if you have a large enough piece of paper and say, you can fold it as many times as you want? Let's try to guess. How many times will you need to have a thick piece of paper? What is the diameter of the universe? The answer is 103 times that. Really? According to my own personal computer, if you have a piece of paper, let's say it's about 0.1 millimeters thick and big enough. With big enough here to understand, large enough that the crop paper is large enough after n times, and a large enough energy source to fold that paper n times. We'll have some very interesting results as follows. After 10 folds, you'll have a piece of paper. It's about the thickness of a human hand. After 23 times, the thickness increases to approximately 1 kilometer. After 30 folds, paper column thickness, when this is enough to reach the boundary of Earth's atmosphere and space at about 100 kilometers. To go on 12 folds, the paper column will be approximately thick. The distance from the Earth to the Moon, about 400,000 kilometers. And if you want to make a video, 24 hours of living in the sun, it's about 150,000 kilometers away. You just need to fold it about 9 more times. Fast forward a little bit. After 83 folds, the paper column will now be about 102,223 light years thick. That's equivalent to about 967 to 1 million trillion kilometers, which is roughly the diameter of the Milky Way, the galaxy that contains our solar system, about 105,700 light years. After 93 folds, paper columns are more likely to be original toilet paper, would be about 100.7 million light years thick, which is equal to the distance that light travels, the fastest thing in the universe. It took 100.7 million years to move, about 990.3 trillion kilometers. To make it easy for you to imagine, then this number is approximately the diameter of super constellation Virgo, or the Virgo supercluster. According to Wikipedia, one of about 10 million superclusters of galaxies that exist in the observable part of the universe. And finally, at the 103rd fold, thickness of paper column, in a relatively accurate way, will fall to about 107.2 billion light years. It's bigger than that. the diameter of the observable part of the universe. At the present time, it's about 93 billion light-years away. You see, even a piece of toilet paper, if imagined correctly, they can also do great things. If you choose to be a fan of the Universe series by Mr. Tan Facts, click subscribe next. These images. It's a space shuttle leaving the launch pad, leaving behind a billowing white smoke. And if so, you don't notice anything wrong in the above sentence. Congratulations on being cheated, rather than being misled all this time by that white smoke-like cloud. It's not actually smoke. It's water, really. We know that if a sound source is loud enough, can break glass, puncture the eardrum, or distort the face, one of the most powerful Avengers, Hulk. This has NASA scientists concerned that sound waves coming from the engines of the boosters, with its size and propulsion becoming so enormous. After landing, it bounces back up, and at some point it'll be big enough to tear themselves apart. What they carry, and even, are the billion-dollar launchers around them. And that's when NASA's water-powered super muffler was born. So basically, this system works like this. Exactly 6.6 seconds before the engine ignition process begins, more than 1.1 million liters of water will be discharged from a waterfall, nearly 90 meters high. These specially designed exhaust pipes, which includes 6 to 8 tall, larger exhaust pipes, and dozens of smaller low-discharge valves. 9 seconds after the rocket left the ground, exhaust water flow reaches maximum. That's 3.4 million liters per minute, or 56,667 liters per second. After a total of 41 seconds, the flushing process is over. Although it's simple in principle, but NASA's water silencer, it's been extremely effective when it doesn't just reduce the intensity of the sound, the noise level of the launcher, greatly reduce the destructive power of sound waves, put out all the fires, which unfortunately arise during launch, but it also creates a kind of phantom cloud of smoke that makes missile launches more Hollywood. We know that an alien race, living the way we are 66 million light years. If you turn the space telescope towards the Earth and look, they'll see dinosaurs, simply by the rays of light that come out of the Earth. 65 million years ago, that were exactly 65 million light years away, similar to the image of the sun you see every day, are all images of the sun in the past. That's 8 minutes and 20 seconds, the time that light takes to go from the sun to the Earth. What this means is, to be able to travel large distances in the universe, photons would require hundreds, millions, even billions of years of wandering. Right, Mr. Tan Facts answer. It's true or not. It's true for us. The photons emitted by the sun will take 8 minutes and 20 seconds to get from the sun to the Earth, and the photons coming out of the Earth, it's going to take 65 million years, the time period equivalent to 1 million human lives, to travel to distant alien civilizations, 65 million light years away. But for photons, they don't feel that long. In fact, they have no concept of time. Why is that? First of all, photons, according to Wikipedia, as a basic grain, and if you like something more sublime, then they're quantum. Understand roughly, is the smallest element of a physical entity. Here is the light. Photons are characterized by two properties: that there's no mass, or have zero invariant mass, and always moving at the speed of light in a vacuum. The emphasis is always moving at the speed of light in a vacuum. According to Albert Einstein's special theory of relativity, time dilation of velocity is the difference in the passage of time recorded or measured by two observers, depending on the relative velocity difference that two observers go through. More specifically, Einstein thought a clock that moves through space will run slower than a stationary clock at the observer's position. let's say under the Earth. The faster the clock in space moves, that's its relative velocity. The larger the observer, the slower it goes, compared to the observer's watch. And when we get to the speed of light, time will stop floating on a moving clock, and of course still running normally on the observer's watch. Or in short, the faster you move through space, the slower you move in time. And as you move through space, at the speed of light, you will stand still in time. What that means is, an object moving at speed, extremely close to the speed of light, that can move in our billions of years, before a second has passed by itself. What that means is, if photons were watches, those clocks will never run either, because they've been moving for a while, for an infinite amount of time. It didn't stop there, because there's no concept of time. Photons won't have time to do anything, including wearing a watch like I mentioned earlier. And they will also, without a sense of self-existence. They have no past, present, or future. The whole process takes 8 minutes and 20 seconds, 65 million years or even a billion years of a photon, since they were emitted, traveling through space, until it's absorbed by your eyes. From the perspective of a photon, it all happened at the same time, and it doesn't take any time. This accidentally makes any distance in the universe for a photon to say, it's just zero. Hello, very happy to see you again in a space-themed video. Maybe you don't know, maybe you already know. It's about 26,600 light years from Earth, near the boundary between the constellations Sagittarius and Scorpius, or to make it easier to imagine, is in the center of the Milky Way, the galaxy that contains you, me, and all of us. There's a source of radio emissions, extremely bright and extremely dense, where it's been determined to contain a supermassive black hole. It's actually a supermassive black hole, or supermassive black holes, the kind of terrorist black hole, the oldest existing in the universe, with multiples of several hundred thousand, up to billions of times the mass of the Sun. It should be noted that the Milky Way is not the only galaxy has a supermassive black hole. In fact, scientists say these supermassive astronomical objects appears in most, if not in all spiral galaxies or elliptical galaxies in the universe. Why is that? Go back to 2002. The astronomers observed many stars soaring into the object in the Milky Way in the same way that a comet soars into the Sun. And if you know how heavy the Sun is, you'll also understand that the amount of energy required to cast a star the size of the Sun, spinning around something, how horrible it is. The only astronomical objects that have density and the gravity is so great, it can only be black holes. And more specifically is a black hole that has the mass of millions of suns, along with the discovery, the existence of a supermassive black hole in the center of the Milky Way. Scientists have also found evidence to confirm that supermassive black holes appear in most galaxies in the universe. Back to the supermassive black hole at the center of the Milky Way. According to a study published in 2008, this supermassive black hole is about as massive, for 0.3 million times the mass of the Sun. With the mass of the Sun, that's the mass of the Sun, and has an approximate value 20 to the power of 27 tons. It's about 330,000 times the mass of the Earth. It should also be noted that that's for 0.3 million solar masses, only relatively true. And it's going to be wrong by the time you see this video, simply because of the black hole are constantly gaining weight by eating the flesh of nearby stars. This sounds interesting at first, but if you think about it a little bit, it's probably going to make you stand for a few seconds. Why? Because people start asking questions. If Sagittarius asterisk has been gnawing at nearby stars, whether in the future it could destroy our entire galaxy or not. And that's what Mr. 10 Facts is about. I'll answer with you in today's video. Welcome to Universe number 3, Supermassive Black Holes. Star Killer or Gentle Monster. Before getting to the main content, maybe you remember the concept of quasars. If you don't remember, Then we'll repeat. They're defined as extremely bright active galactic nuclei. It's said to be extremely bright because quasars are extremely bright. More specifically, they engulf the light of it all, the other stars, completely eclipsing the galaxy itself that contains them. And even though it's very, very far away, they still appear in the night sky, under the shadow of a dim star. That's why they're called quasars. That is, star-like objects. Still according to that, the farthest and oldest quasars ever known by man. It's called ULASJ13 for 2 + 0928. It's 29.36 billion light-years from Earth. What's interesting is that quasars and supermassive black holes thought to be two, but it turns out it's just one. Quasars are basically hungry supermassive black holes. They eat so much, material accumulates and form a hot accretion disk around them. And if you're wondering, hot piles of material waiting to be eaten on that accretion plate, where it came from, the answer is very simple. It's from the unblessed stars. Unfortunately, it's near these supermassive black holes. Let's go back to the question at the beginning of the video. Supermassive black hole material Sagittarius at asterisk. It's getting worse, knowing that all the stars in the galaxy, including our own sun. The short-term answer is no, and in the long term and in the very long term, not really. More specifically, the supermassive black hole at the center of the Milky Way. It's not a quasar. It means this young man's eating speed is still quite moderate, and slowly even if in some way, that Sagittarius asterisk becomes a quasar, even an extremely bright quasar, which means having the speed of eating cattle, we're more likely you won't be able to tell the difference from a distance of 26,600 light-years. Because in the end, even though black holes sound dangerous and scary, also, it's just the concentration of a huge amount of matter in a very small part of space-time, if far enough. A star that can completely orbit a black hole in a peaceful way, in the same way that the Earth and the other planets go around the Sun. So in fact, scientists think that replacing the Sun by a black hole of exactly the same mass as the Sun, it's almost not going to change anything. Ignore the fact that every known form of life will freeze to death. Earth and other planets in the old solar system will continue to orbit this new black hole in an orbit, just like when they're orbiting the Sun, for billions of years. Simply because of the gravity generated by the Sun, it's going to be exactly like the gravitational pull of a black hole, with the mass of the Sun. And in case you've forgotten, the Sun itself and about 250 billion other stars in the Milky Way has been orbiting the center of the galaxy that contains the supermassive black hole Sagittarius asterisk for billions of years and remains safe. To be eaten by a supermassive black hole, any unblessed star would need to have a direct collision with the supermassive black hole, or at least fly very close to it. And one of the most likely ways for that to happen, that's when a star's orbit changes, when it interacts with the gravitational pull of another star. But this is extremely rare in practice, because if you can't imagine it, the average distance between the stars in our universe up to 4.15 light-years. That's equivalent to about 39.6 trillion kilometers. Meanwhile, the diameter of the Sun is only 1.39 million kilometers, and of the universe's largest star, UY Scuti or BD1-5055, it's only about 2,374 billion kilometers. In short, in the short term, supermassive black holes like Sagittarius asterisk are completely harmless, especially with the races living on the outskirts of galaxies like us. However, if somehow that man possesses inwardly immortality and can swing with the eternity of the universe, there's going to be situations where you need to get the pen and paper out. Record it in case. The first scenario will come in about 4 billion years, when the Milky Way and the neighboring galaxy Andromeda merged into one to form Milkomeda or Milky Andromeda, an event that we'll show in another video about the scary facts. But maybe it's not so scary about the universe, as we mentioned earlier, in an event that's lasted for millions of years. To star clouds with a total of about 1.3 trillion stars will not stop fighting each other. And even though direct collisions are extremely rare, the chaos will cause the orbits of countless stars to change. Some will be ejected from the newly formed supergalaxy. Some with less dignity will be thrown straight towards one of two supermassive black holes. Are extremely hungry with supermassive black holes at the Andromeda center. It is said to be a monster when placed next to it. Sagittarius asterisk. When you have the estimated mass between 110 and 230 million times the mass of the Sun, compared to just 4.3 million times the mass of the Sun of Sagittarius asterisk. In the end, two supermassive black holes merge to form a quasar. To continue my coffee drinking days. After billions, trillions, or even trillions of years, many other galaxies will collide with Milkometer to form even more massive supermassive black holes, pushing more stars with poor dignity who like to suck into the bosom of the monster at the center of the galaxy. I agree that the story has gone too far, and it's no longer our concern either, and our ungeneration descendants. But let's just try one rewind to the end to see the movie with the galactic monsters. How will it end? Following that after the Milky Way and Andromeda, cleaning up all the other galaxies in your neighborhood. It becomes a supermassive galaxy, has a supermassive black hole at the center. The other stars in the galaxy, there's a lot of time to interact with each other. Some will be ejected from the super galaxy, others were thrown straight at the monster, super black giant. Others will be saved. Let's say they can avoid any adverse interactions during a Google year. No, it's not Google. This Google is 10 to the power of 100. With 10 to the power of 100 can be presented as digits as a number followed by 100 zeros. Can you shape it yourself? But why a Google of the year? Because this is the time it takes. So that a supermassive black hole has about the mass of a galaxy, about 100 billion times the mass of the Sun, completely evaporated through the emission, Hawking radiation. For those of you who don't know, even though nothing can come out of a black hole, the entity itself is emitting a kind of radiation that's capable of reducing their mass. What that means is that if you're not fed, even a supermassive black hole entity, known as the monster of the galaxy, by some young man, it's also possible to starve. In short, at the present time and in a sufficiently distant future, supermassive black hole Sagittarius asterisk at the center of the Milky Way, it's not a threat at all to the existence of life on Earth. The scientists say that from now until the Sun dies, about 5 billion years from now, this supermassive black hole will not be able to interact with us in any way and will only tear apart a handful of stars. That's it. But if our children and grandchildren can live long enough, they will be seen. A Sagittarius is very different